Well, we're actually, we're not winding down. We're not winding down, but we're getting to the point where we're getting close to ending organic chemistry. And but we still have a lot to do. We still have a lot to do, and so I'd like to go ahead and do a little bit of work today. And I'd like to give you some advice. My advice would be, if our test is next Thursday, that gives you a whole lot of time to get your homework done. But my advice would be that if you're not looking at the chapter has lots of solution, sample problems and stuff. That's what I would do, just kind of leaf through the chapter. And one more advice I would have is, they're going to go through, do you remember all the functional groups? I'm going to do one today, but remember all the functional groups? You guys did a good job presenting those the first time, but you might want to sit down and say, let me just make like a little index card, and let's do the functional groups, and let me write little notes in here, because that's the part, and how do you name that? How do you name an alcohol? How do you name an aldehyde? And so that's what I would like you to do. Since we already did functional groups, I won't be spending as much time on it. I'll go give examples. How do you name that? How do you name that? And a large part of the test is naming compounds. And those are all, almost all of those are multiple choice. So you say, no, that can't be the name. Oh, that can't be. Oh, it's got to be one of these two. Oh, yeah. Yeah. So, all right. Anyway, what I would like to do on Monday, I'll probably go over the functional groups, okay? I'll go over the functional groups. I'll be kind of fast, but we already had them once, but I'm just going to go over them again, how to name them. And then I'm going to start the polymers. And since we already did some of the polymers before, I'll skim over that. But I will do, what I'm going to do is right here. And starting here, this is something you haven't had since 9th grade. In 9th grade, you actually did a small unit, which you didn't understand it probably. But remember how you had, proteins, carbohydrates, remember that? So those are, and lipids, remember that? Something like that, okay. DNA, remember DNA? Okay, of those four things, 3 of them are actually called polymers. And so I'm gonna go over those, and I'll give you a handout sheet and that kind of thing there, so I'll kind of jog your memory on that. I'll also on Monday give you one of these, which is amino acids. And I'm going to have you learn 3 of those and 3 of those. And the easy part of it, every amino acid has this in common. See the black part? They all have that in common. So all you have to learn is what is attached to, okay? So what I'll do is I'll give you a choice. I'll say, here's the one I would learn. But the easiest amino acid here, and these are, some of these are polar and some are non-polar. And so anyway, starting on Monday, I'll do a little bit of the functional groups, and then eventually we'll do Tuesday and Wednesday. All I do on Tuesday and Wednesday is go over kind of biological polymers like that. Okay, so I don't want you to get, what I would do this weekend, if you have a chance, is maybe a little note card and look at the functional groups, and as you read through here, just say, oh yeah, look at that, that's right, see? And make a little note card for each functional group, and I think you'll be in very, very good shape at that point. All right, let's go over here one more time. They, with the benzene ring especially, they do have a naming system, and this could be called 1,2, dibromobenzene, okay, fine. And this could be 1,3, and this could be 1,4. Now, I didn't do this. I'm not even sure why the organic chemists thought it was they needed a shortcut way of doing it. I'm not sure. But they did the ortho, meta, and para. And ortho means we're right next to each other. Meta means skip one, and then para means we're kind of across the ring from each other like that. So if you want to just memorize OMP, right? Not OMG, but OMP. Yeah. So maybe you want to do that. And if you use the ortho, meta, and para, you don't use the numbers with it. So I will tell you that if you met an organic chemist, they will use, especially with benzene ring, they're going to use those abbreviations all the time. There's a thing that you probably could find in the hardware store now, but they don't sell it like they used to. It was called paradichlorobenzene. Paradichlorobenzene. And that's called mothballs. And so what happened is people used to, when they had houses were less sealed and they didn't have air conditioning, you'd open the windows a lot. And it was very, very common. If you ask your great-grandparents, maybe they're alive, they would have had a lot of trouble with moths, okay? Moth would get in a house, they get in your closet, and then they would go eat some of the fibers. And you see sometimes TV shows where somebody pulls out a sweater and it's got holes in it. That's the moth eating the holes in it. And so people had different ways around that. One of them is if you had enough money, you could have a cedar chest. The wood called cedar gives off an odor that insects hate. They hate cedar. And so if you had a lot of money, you'd have a closet lined with cedar. And you could put anything in there and the moths wouldn't go in there. Or you had a chest at the end of your bed, a cedar. Anybody heard of this? Am I just making this up? Have you heard of this? Oh, good. Now, if you didn't have very much money at all, I don't have money to buy a cedar chest, I go buy some mothballs. And what you do is mothballs, you put them in a drawer where the sweaters are, and then they'd stay out of there. Anyway, that's called para-dichlorobenzene, all right? And I just want to tell you, I'm not teaching you something that is not, they do use those abbreviations like that. All right, last thing I want to show you, next thing, sorry. The benzene ring is really big. It's pretty big in organic chemistry. And here's some things. Here's a double benzene ring. That's called naphthalene. Now that is one. I think they used to use that for mothballs. Now I use para-dichlorobenzene, I think. Here's another one. Here's another one. And you can see how benzene rings can be used to make lots and lots of things. All right. Yes.
Because in order for there to be a benzene ring on both sides, the two carbons that are in the two rings,
They would have to lost their hydrogens.
okay,
So on a benzene ring, normally you'd have one hydrogen. Each carbon would have one hydrogen. So you're right. They would have each of these two carbons would have had both of them have to have lost their hydrogens, right? That's a good question. Good insight. Yes.
For the last example, it says 3,4-benzpyrene.
Luckily, we're not worried about naming. Like I said, there's millions of organic compounds.
I was just going to ask.
I would never ask you to do that. What's it called? 3,4 what?
Benzpyrene, I guess.
Wow.
I was wondering what the 3 or 4 mean in that, because
Wow. I'm not honestly tell you I don't know. I don't know. I certainly don't know that area of organic chemistry. Great question. No, I just don't know the answer to that one. All right, let's look down here. This is something that you're going to see when you do your functional groups. You'll see that chemists like to everybody likes to classify things, but notice that if you had an alcohol that, and remember the alcohol group? Remember how the alcohol is COH? Remember that? Okay. If you're an alcohol and that carbon, COH, is only attached to like one other thing, whatever it is, it's like I'm sticking out here, right here, CH2OH, but that's called a primary alcohol. Primary means I'm only attached to one other thing. But look at this alcohol group. How many is he attached to? 2. And you can draw it this way or draw it like that. That's called a secondary alcohol. And then what about this alcohol? I'm attached to 3 different things. That would be called a tertiary alcohol. And as you read through the functional groups, the same thing happens for amines. I'll show you another page. I'll show you another page where they do amines. Anybody find that for me? Here it is. So when you get to this page, you said, how would you classify that? Amine is NH2, right? All right. That's a primary amine. And what about this guy? Well, this nitrogen is attached to 2 other things. You see that? Like carbon, it might be carbon here. Secondary amine, and here it's a tertiary amine. So they'll use that same idea on alcohols and things like amines. All right, let's go back here. And you guys had the alcohol, didn't you? Okay, so I think you, on the packet you guys had, I think they showed, didn't they show this reaction here? We started with ethene, do you remember that? Is that part of your report? Like, they started with ethene, which has a double bond, and they force water onto it, and there's some catalyst. Everybody get the catalyst? And what they do is break the double bond and form OH on there, and that's how they make ethanol. And that's how they commercially make ethanol. But I don't think your package, did your package say anything how they made methanol?
We talked about it using water and like some other. Didn't actually get to the formula.
You remember using carbon monoxide?
Yeah.
I don't think your packet mentioned that. Okay, so over here we noticed that, and you did a good job. You said that by far the most alcohol is actually methanol, isn't it? Because it's used in so many other industries. And here they actually use carbon monoxide and hydrogen with some catalyst. And again, I didn't discover that. I'm not sure who discovered that. I'm not gonna ask you to memorize that. But somebody discovered that if you have these catalysts and you add carbon monoxide to hydrogen, you can make methanol. So anyway, I just thought you might find that interesting. Okay. How about these? What do you think about the functional groups? You think you can? I'll tell you what. Let me cover some up here. All right. If I cover these up, do you think you might be able to remember them? What about this guy here? Do you know the name of it? What is it? It's an alcohol. What's the name of the COH group? Oh, I'm out of time. I'm sorry. I apologize. Okay. Anyway, remember we had hydroxyl, carboxyl for acids, and anyway, have a good, thing. And if you have some time, maybe make those index cards, and I think you'll be in pretty good shape. Yes.
I have a question. On the quiz, for the one that was, this one, so I just did the stick structures of the carbons.
I'm all right with that.
Is that okay?
Yeah.
Okay.
See, I'll be able to tell, like, if these are, like, up here.
Yeah.
And,
I just saw that you had the hydrogens there too, and I wanted to make sure.
I think I'm all right with that.
Okay.
Normally, though, I guess you'd want to show these because
Yeah.
you don't even have this in alkanes. You only have it for an alkene that it's in the middle somewhere. I'm all right with that.
Okay.
And I think if I did, so I drew this one correct, I think, but for this one, if I put the H's on the last carbon, is that incorrect?
Well, the last carbon does have H's, but
Like I put them on the same side.
I'll look at it.
Okay, thank you.
So here is
Oh.
the chocolates and
Oh,
all of that. And I can come back at break to see, to
all right.
check it with you.
I have 2 classes in a row, but I tell you, at break we can talk. How about that? At
Okay.
break we can look at a couple of them.
Okay.
Yeah, if we could confirm that those are the correct answers, I'd like to have that, and
And I could write it up. And
well,
type
if you
up the
really,
right answers.
as long as I could read this really well and I could print it, then I could just hand it out if I wanted to, or I could give you another one. You could do it. It's really not too bad. It's kind of neat still.
Okay. But I'll come back during the break so we
Okay.
can look at it.
All right. How'd you do on the quiz? Are you good with the isomers?
I didn't name, I was kind of confused on these. I hadn't memorized them. So I looked at them as like finding the parent chain and attaching CH3.
This is like a branch. See, that's what I was telling people. This is like a branch, and that's why I drew this little cloud for you guys. But so if this thing's attached to whatever, if it's attached to a benzene ring, attached to whatever, what would you call this branch? And it's 3 in a row, so that's just propane. But here, notice that the branch, see, it's like that. And remember how we did 2 different days? I said, make sure you know your branches. And that was like, several days ago. And then,
I got this.
okay,
and,
what about that one? A little bit harder. Because this guy locks in the number
I
system.
think I counted it wrong. I didn't know. Maybe I did.
How about that one?
I did not get it.
Okay.
But I know I got
Did you
this
know
one.
cyclo, though? I use cyclo for ring structures, like, cyclobutane, cyclohexane, cyclopropane. In this case, instead of propane, it's propene. That was I think that was the hardest one. How about these?
I think I got those pretty well.
You had 9?
Yes, I had 9.
Oh, good. That's a good
But there
thing.
was one I wasn't too sure about. So maybe.
And it's hard not to repeat one, too. That's another thing. All right, thanks.